Writing complex formulas is a bit like Lego. You could get all the ingredients, but if you don't know how to combine them, you wouldn't be able to make something beautiful. And when you know how to combine everything, you will end up creating something pretty like this. In this video, let me explain how to create complex Excel formulas using the basic ingredients that you may already know, like the sum function, the VLOOKUP, or the if formulas, etc. We're gonna look at 5 real-world Excel complex formula situations and develop formulas from scratch. Let's jump into Excel. The 5 examples that we are gonna cover are best GPA student name from a list of student names and their GPAs, best salesperson within a territory where the territory is given as an input, and then extracting the last name from a bunch of names where there is either a single or multiple middle names, a complex nested if formula to calculate the bonus per department, and finally a mystery formula to calculate manager's manager. I call this as a tongue twister, so feel free to say it a few times aloud. Manager's manager mystery. For our first formula, we shall calculate the best GPA student name. So here I got some students and their grade point average. We got about 40 students here, and I want to know who is the student who has the highest GPA. Mind you, we don't want the highest GPA, which can be calculated with a max formula. So I could say max of my range, and I will see that my highest GPA is 4 points. But that's not what I want. I want to know who that person is. So this is where we could use a VLOOKUP or XLOOKUP or anything like that. I'm going to use XLOOKUP. The value that we want to look up is 4. We could type 4 here, but that would be wrong. Instead, we want to do it by first calculating the maximum. So maximum of the GPA values. So you can see that the first parameter itself is another function, and then the lookup array is the GPA itself, and then the return array is my names. So C6 to C45. We can see that OBM is the person with the highest GPA. Now, how do we calculate the second highest GPA or the names of the top 5 students? So second highest GPA is a similar formula. So I'm going to be lazy here. I'll copy this, paste it here. But where it says max, instead of max, we will use a different formula. This is called large. What large does is it takes an array and then it can give you the second highest number, fourth highest number, like that. The first parameter for large is my input data. So this is my data. And then the second parameter is number 2 because we want the second highest value. So this will look up, get the second highest value, and then look up that in the GPA column, get the corresponding name, and then we will see that it's Arial T. Now let's add a bit more twist to this formula and then figure out who are our top 5 students. This is where you could be tempted to write more large formulas, and that would work. So first I'll show you that approach. So instead of this, which will be just Arial, where it says 2, if you were to put an array, for example 1, 2, 3, 4, 5, because we want all the 5 people, we'll get their 5 names. They'll go sideways. This is because the 1, 2, 3, 4, 5 are using comma as a delimiter, which means one column at a time. But if you change this to semicolon, they'll go like this. This is one formula. But remember, this is an advanced Excel formula tutorial where I'm teaching you how to write complex formulas. So let me show you another method. I'm going to delete this. And the other method that we could use is, instead of using large or any of those things, we are going to use this newly introduced function called sort by. What sort by does is it will take a bunch of values and then it will sort them by another array. So here I want to sort my students by their GPA. And then the GPA needs to be in the descending order. So the order will be -1. This will kind of list all the 40 students in the descending order of their GPA. So we'll see not just top 5 students, but everybody else as well. Once this list is obtained, we then want to limit this for just the 5 people. So here you could use a function like index, send the sort result to it as an input, and then the row numbers that we want are 1, 2, 3, 4, 5. And again, it will give you the values sideways. Now, because we need to generate these 1, 2, 3, 4, 5, you don't have to type them either. You can use another function like sequence. I want the sequence to appear in rows, so we will say 5. What this will do is it will generate 5 numbers in a row, and then that will give you the values like this. I hope these formulas are making sense to you. If you have any doubt, feel free to either rewind the video a few seconds or use the download sample file to refer to the exact syntax and how I got there and then understand it better. Let's look at the second one. Our second problem is best salesperson by territory. Now here, instead of having data in a range, I put that in a table because this will give you a chance to write better formulas but also expose you to different way of dealing with structural references. So here my data is in the sales table and I have salesperson, territory and the amount they have generated. What I want is based on the input cell here, H5, I want to find out who our best salesperson is and how much is their sales value is, as well as what is the fraction of that number as against their total sales. So all these 3 values we want to calculate. Let's go with the best salesperson. The approach here is kind of similar to what we did earlier, but because we don't care about the best value across all data, we just want to have the best value within Nagpur, we must first filter the data. Again, this is where Office 365's new functions make the job whole lot simpler. If you are using an older version of Excel, calculating best salesperson becomes a complex array formula. Whereas with this, all I have to do is filter my sales data. So we are interested in the salesperson's names. So we'll say sales data. We'll work this formula in step-by-step fashion. So you'll see how the inner workings are. So we'll say sales. I want to see sales of territory is equal to this value here. And what this will do is it'll simply give you a cut of the Nagpur data. Within this, I want to then find out who is our best salesperson. So we then send this to sort, and then within the sort function, we'll say that you need to sort this on the 3rd column in descending order, so that the best salesperson within the Nagpur kind of ends up on the top row here, OBM, Nagpur, and that is the amount. Now we don't care about any of these other values. We just want their name here. So once the sorting has finished its job, we then want to send it to another function through which we can extract the first row, first column value. This is where my index can come in handy. Index of all of that, 1, 1. So take that entire range or array and then get me whatever is in the first row, first column, and that'll give you OBM. Now, what is their amount? The amount is very simple. We already know their territory and their name. So we can use, for example, a function like SUMIFS of sales value, where salesperson is this person and sales territory is Nagpur. So we'll get that amount as well. You could get the amount in other ways as well. You could have used another filter function and then used index as well. But I wanted to showcase this method as well. So we get their name, their amount. Let's just quickly double check. Here we can see that that is their value. If I go and filter for Nagpur, that's the highest value there, 1.6 million. Because this is an input value, I can change this. So for example, I can look for Chennai and then we will see Susanna G is our best salesperson there. What is that amount as against all of Susanna's sales? Well, we just have to calculate their total sales and then divide it with that. Their total sales would be another SUMIFS function. SUMIFS of my sales amount, where salesperson is this person, and then we will see that their total sales is 5.4 million. We just take this value, put that in the front, calculate that, and then apply some percentage formatting, and you can see that answer here. We crunched a lot of numbers so far, so now let's take a look at some text-based formulas. I got some names here and I just want to extract their last name alone using a formula. Let's take a look at it. So from with these names, I just want to get their last name. I randomly generated these names. I'll show you two approaches. One is using a formula, but the other is not using a formula. So last name, I'll call this as no F because no formula. And this is a very simple thing. All you got to do is type a few values. So I'll say Tam and then Banchotsen, well, whatever that is. And then as soon as you finish typing a couple of values and press enter, Excel figures out the pattern that you are going for and extracts the values. This feature is called flash fill. So flash fill is an amazing time saver using which you can do these kind of things very quickly. Of course, flash fill comes with a limitation. It is manual. So if your data changes, so for example, here it's not edX, it's, I don't know, open. And what happens is this value doesn't change. You will have to go and rerun the flash fill option again from your data ribbon. So here is flash fill. Now let's take a formula approach here. Let's first observe what we need to really do. The last name is any word appearing after the very last space in the full name. So all we have to do is locate the last space and then move one character further, and from that point extract everything. To find the last space, we must first count how many spaces are there. To count spaces, we can use a function like substitute. So we can say this like this: substitute in this text, in my full name, space with nothing. So this will first remove all the spaces, and then we can measure the length of this, and it will be like 20 characters. And if I measure the length of my original text, subtract this from that, I'll get how many spaces are there. So here in this particular thing, there is 3 spaces. In this guy, there's 2 spaces, and here there's only 1 space. So once we know how many spaces are there, we just have to locate the third space or second space or whatever, and then get everything afterwards. To do that, we will again use the substitute function. So we'll say substitute in the full name. My old text is space. My new text is a character that is not part of the text. So it could be something like an @ symbol. Usually within the name, you won't have @ symbol. And then the instance number, which is the last optional parameter for substitute, is the number of spaces. So notice this construction here. We're saying within full name, replace the space with @ only for the very last space. It will get you a name like this. So everything @ last name, everything @ last name. This is how our name gets converted now. And at this point, all I have to do is find where that @ is and then extract everything afterwards. So we will then use the find function. So find @ within all of this text. This will say I found @ at 19th position, 18th position, 9th position. Now that we know the position from which we need to extract, we can use the function like mid. So mid of my text, start from 19, well technically +1, so we'll say +1. And then the number of characters that we want is everything after that. So we'll put a very big number like 999, and then this will extract the last name for us. So this is a formula based approach. This is a very long formula and not really advisable that you write these kind of formulas every time or write them in one cell like the way I have shown. So you got 2 options. Number 1, obviously you could use the flash fill method to fill up the data if it is simple and one-time thing. But if you got to do this kind of last name extraction on a more dynamic basis, consider using other features in Excel such as Power Query. Power Query is built for this kind of things, and it offers a more simpler and shorter syntax for handling text cleanup activities like this. If you are new to Power Query, I highly recommend that you learn Power Query at the very earliest opportunity you get. I got a beautiful video here on my channel that talks about Power Query at length and gives you all the detail about it. So check out that video when you are done with this video if you are looking for another method. If you are happy writing formulas, of course you should just do what I have done, and if possible maybe break it down into 3 or more columns, otherwise write in one go as I have shown. Let's get into the 4th example. For our 4th example, we want to calculate the employee salary bonus based on some really complex criteria. The idea here is to just show you how to write such nested if conditions based on real world situations. So here, to give the bonus to employee, our company Awesome Chocolates has the criteria that if you are a female employee in either website or sales department, you get 5% bonus, 5% of your salary. If you are a female in any other department, you get 4%. anyone joined before 2019, so you don't pass either of these two conditions, so then anyone joined prior to 2019, you will get 3% bonus. All others with salary under $100,000, you get 2% bonus, and everybody else gets 1% bonus. So this is the criteria. Let's see how we can code that using a formula. For the purpose of this, again, I'm not using a table, I'm using a spreadsheet cell references, so you can again see a variation of how this formula development works. So we could use a couple of different functions. You can use either if or the newly introduced ifs function, whichever you feel comfortable you use. I'm going to use the ifs function because this will allow you to write slightly shorter formulas if possible. So the first test is we want to test, when you're testing for these things, sometimes the criteria and the order in which you need to test may not be exactly in sync, but in this case they are in sync, so we can just write it the way the criteria is spelled out. So we want to test for whether your gender is female and your department is either of website or sales. So it's an AND condition. So AND of this thing here, D6 is my column, D is my gender, so D6 is female, and then we want to check if your department is either of website or sales. So we will use an OR condition inside that. OR of E6 is equal to website, comma, E6 is equal to sales. You satisfy both of these conditions, which is your gender is female and your department is one of these two, you're getting 5%. We'll move on to the next condition. Else, if you are a female, so that means your gender is equal to female. We don't care what department you are in, when you join, how much your salary is, you're still getting 4%. Our next condition is anyone joined prior to 2019. So we'll look at this condition here. Date joined, which is in column F, is less than, and then we'll construct a date which would be 2019-1-1. So if your date of join is before that, then you are getting 3%. If you are not meeting this condition, that means you have joined after 2019, then our condition now comes to column G. So we are looking at column G here, and if your salary is under 100,000, if so, then you're getting 2%. Else, you should be getting 1%. Now, when you are using the ifs function, there is no else option. Everything is condition output, condition output. So all of these are there. Then the logical test, last one is true, which means if none of those are true, then this will automatically kind of trigger and it will give you 1%. So this is the output. Let's just quickly apply formatting and then fill this down. There is nobody getting 1%. This is because we don't have any staff that have joined after 2019 and having a salary of more than 100K. We can verify this here quickly. If I look at my date joined and simply filter down to 2019 people, everybody's salary is less than 100,000. So everybody is getting 2%. But what we could do is we will look at one of these male employees and we'll bump their salary up to 150,000. Automatically their bonus becomes 1%. Otherwise it is 2%. Okay, we have come to our fifth and final example. This one is a tongue twister, as I said. Manager's manager mystery. Let's take a look at it. Here I have got some sort of a nested data. Well, not nested, but more like hierarchical data. Here I know our employee name and who their manager is. So for example, Abraham B, their manager is Theobald M. And you can see that Theobald M is also in our data, whose manager is Wilma B. And Wilma B's manager is Jack S, and Jack S manager is Zorana D. And Zorana D doesn't have any manager because she's the boss of this company. So what I want to do is, based on this data, I want to find out who is the manager's manager for Abraham. So in this case, we want to find Theobald and then go and find Theobald's manager, which is Wilma, and print that name there. And we would like to write one formula and apply it across the table consistently so that everybody, we can see who their manager's manager is. In a way, this is like a weird lookup formula. All we got to do is look up this person's manager and print it there. So it might appear like a complex problem, but once you identify the pattern, it becomes easy. So we can again use VLOOKUP or XLOOKUP. I'm going to use XLOOKUP because it is a simple formula to write. I want to look up this manager in the person's column and then get their corresponding manager. So notice the pattern here. We are saying look up Theobald M in the person column, and then if you find Theobald M, then get me their name, manager's name. It will come up here with everybody except these two. These two have something funny going on. So, and here as well, Zorana, whoever is reporting to Zorana D, because she doesn't have a boss herself, it'll kind of create this funny situation. So once this is done, then we can use the if not found option. So we can print the word no boss, and that will kind of solve the problem here. What about these zeros? Well, technically that is correct, because what is happening is for Jack as Zorana D is the boss. For Zorana D, blank is the boss. Now Excel reads the blank cell, it treats that as 0. So that's kind of how this is coming up here as a 0. What we could do is we could kind of tweak this a bit and then suppress the 0. There are a couple of ways to do this. My obvious choice is you can go to File, Options, and then from Advanced, locate the display options for this worksheet, and then from here show a 0 in cells that have 0 value. Uncheck this. When you do that, wherever there is a 0 through the formula or whatever, it will appear as a blank. Now you may not desire this behavior. If that is the case, you could go and write some extra conditions here to kind of suppress the 0. But to be honest, it's not of any value, so I'm just not going to bother with that. I hope you liked that. Now, if you want to learn how to write advanced if conditions to simulate various business problems, check out my video that is shown on the screen. It talks about 10 advanced if conditions and how to set them up using Excel. Now, if you excuse me, I'm gonna go and play with my Batman Lego set.